We are now live, ladies and gentlemen. We are now live. Welcome to 8th period, ladies and gentlemen. Please don't use that word. Please just for today, please be real chill, okay? Do you have a phone with you? Can you call her and handle that? Okay. Oh, you know what I could do is just copy this and paste it into 8th period. Yeah. This is unbecoming. One of our best students is not happy. Let's get together, please. Huh, that didn't copy. I copied it. Copy. And then paste. See? It's not, it won't let me paste. Oh, wait, there. Whoa. All right, well, I'm tired of messing with this. Feel like I've wasted enough of your time. We'll figure that out later. Yeah. Let's not. let's make discussions about. Oh, perfect. It copied. All right. Yes. I have Rotary Club on Mondays. All those tutorials have to be made by appointment. Absolutely. I thought you had tumbling. Because I have. You'll figure it out. No, just find the one that's open. It's not. It's a Twinkie coffee. Just get a handful. Take them back to your desk. I'm very sanitary. Okay. I don't touch them. Okay, here's your first problem. Under test review, this is a table that. Hey Mac, this is a table that we're going to complete. Alyssa, to the front office. Alyssa, can you take this and throw it away? Okay, guys. So the reason this is not in standard form is because on the right side, 12, and that can't be there. It's got to be a 0. So the way that I move the number like that over to the other side, which is where it needs to be, is by doing the opposite operation. So, yeah, right now it's plus 12, so we minus 12. on both sides. And when we do that, we can rewrite the quadratic equation in standard form. X squared minus x minus 12 equals 0. I want you guys to take a minute. And make this table. And I'll try, you know what I thought I would do is just for today, it's not so important because I didn't tell you in advance, but I'll try to get you a table because for every quadratic equation, we need to be able to do all of these things. Standard form, x1, x2, vertex, y-intercept, point of reflection. That's what POR stands for. Domain, range, and axis of symmetry. So 9 things for every quadratic that you do. Luckily, we're going to do the calculator, so there's nothing you have to do. The only thing you have to do by hand is go from whatever you're given to standard form. You have to do this by hand. Once you get it looking like this, you are good to go. You can go pencil down after that. Okay? So let's consider the first thing. We're going to find the left x-intercept. So go to your calculator, x squared minus x minus 12. Go to your calculator. Make sure you clear the memory. Second plus 7, 1, 2. Then go to y equals. And we're going to type in only the part that's the equation, the quadratic part, not the equals 0, just the standard form. Yeah. X squared minus x minus 12. And now what we want to do is just hit this graph button right here. Now, if we look closely, we can actually see where this thing is crossing the x-axis. Okay, it's crossing right here. It's crossing right here. So this is x1 and this is x2. What I need are the coordinates at these points. So you need to make sure that your calculator is showing this. So the way you do it is you just go, let's see, -1, -2, -3. So -3, 0 is a solution. That's an x-intercept. Okay. This is the solution, -3. -3, 0 is the coordinate point at the x-intercept. Over here is x2, 1, 2, 3, 4. So x2 is +4. That is the solution. And this is the intercept, 4, 0. Okay. So we found x1 and x2. Let's go back to our document. Oh, I see I deleted some stuff behind it. And fill in what we know now. Anna, did you text your mom? Okay. Just make sure that with at least 1 day's notice, we have a scheduled appointment, because otherwise I might have something scheduled after work, like doctor's appointment or something. Tomorrow is great. Tomorrow I will be here for sure. Yeah. Okay. Okay, so what were the coordinates at x1? What were the coordinates at x2? Now I'm going to show you how to find the vertex, okay? Zoom out by hitting zoom 3, enter. You have to be able to see the bottom of the hoop, okay? See this right here? It's very, very subtle, but there's a difference between the y-intercept and the vertex. Can you see that? It's slightly different. You can't see that? Okay, so where it hits the y-axis is slightly above where it's actually the bottoming out. All right, so what I want are the coordinates of this point. This is called the minimum of the graph. Okay, and what we're going to do, and you guys have seen this, is we're going to mess with the calculator and you're going to put in a left boundary. Okay, looks like this. You know, you have that little blinking cursor thing, and then you're going to put in a right boundary. All right, and then it's going to say guess, and you're going to hit enter, and then it's going to give you the coordinates right here. Okay, so the way that you do that is you hit second, trace, minimum. And then you do the steps, left bound, right bound, enter. Couldn't be easier. But if you're just sitting there not doing anything, it's impossible. Second, trace 3 is the minimum. And then you want to go to the left of the bottom of the hoop, enter. Make sure you are clearly on the other side of it. Give yourself an enter again. Now you got 2 vertical brackets, and then hit enter again, and it gives you the minimum. Okay, let's talk about this minimum here. So, what do you think this is going to be like if it was a multiple choice? When you see that some of you guys are more familiar with these calculators than others, sometimes it spits out a number like this, and you have to know that it really means x equals. Okay, you got a round. Okay, over here, it's finite. All right, so the vertex is located at 0.5 comma negative 12.25. That's the vertex. Okay? Raise your hand if you don't understand how to obtain it. Yes. Okay, let me do it again. You watching this right here? Hit second. Well, let me back up. Does your screen look like this? The graph. Do you see the graph on your screen? Oh, can you help her, Rodnisha? You need to zoom out. You have to be able to see the bottom. Zoom 3, enter. We'll zoom you out. Now, okay. Hit second. Trace. Oh, I've hit second. So second trace, and then go down to minimum, which is 3. Hit enter. what you found was the y-intercept. No, hold on. Well, I'm just going to answer Armani's question real quick. So Armani, you need to bracket your left and right bound better. So you're right now, you want to put the left bound definitely over to the left of where the bottom of the hoop is and hit enter. And then your right bound, hit that right arrow key until this thing is definitely over on the other side of the bottom of that hoop. Hit enter. And now it'll guess it. It makes it possible for me to do my job. Sure. I would never, ever do that. And let's not talk about that. Okay. 5 comma negative 12.25. 0.5, sorry, comma negative 12.25. Now Armani gave us the y-intercept, which you can just read off the graph, okay? It's always the thing that's over here in the C position. Negative 12. Now, how would you say negative 12 as a coordinate? Can you bring me your calculator really quickly? Okay, now let's talk about the point of reflection. So let me show you what that point is actually on the curve so that you understand what we're trying to find. Yes, okay. Now you need to zoom out. Let me check your, okay. You hit graph and then zoom 3, enter. Let it redraw. You can now see the bottom. Okay, so hit second, trace, 3. Click over to the left, enter. Click over to the right, enter, enter. 0.5, comma, negative 12.25. You're very welcome. Now, hold on. Okay, go. Yeah, go on. So the point of reflection is hard to see on this graph, but it's if this is the y-intercept, okay, and that's not the y-intercept. We're trying to find this point right here. We want to see the reflected point. So I want to show you how to do that easily because there's nothing way to do in the calculator. But read this. Can you see this tiny little writing? Two times the x value of the vertex, comma, the x coordinate of the vertex. What's the x coordinate of the vertex? 0.5. So what's 2 times the x coordinate of the vertex? 1. Okay. So we're at 1, comma, and then just the y-intercept. What is it? 1 comma negative 12. All right. That was easy. The point of reflection. I don't like how. I'll write that later. Point of reflection. Okay, now domain. Domain is the same for all quadratic equations. Okay, so we should probably note that. And I'm going to tell you what it is, and then it's going to be your responsibility to remember this forever. It's easy. All real numbers. Now, the way that inequality notation shows that on the star test, negative infinity, less than or equal to x, less than or equal to positive infinity. Okay? The third way you see it written is like this. The weird looking R. The other way you see it written is like this. Basically, some way of saying every number. I can only answer as a free man. You can do what you want. Well, let me answer that by saying, if I were you, I would. But I'm not you, so I'll leave that up to your freedom of choice. Okay, now the range. This one's a little weird, but it's easy. So little tiny writing, here we go. The range is the y coordinate of the vertex less than or equal to y less than or equal to infinity if minimum. In other words, if it's an upward pointing line and you have the bottom is the minimum, then your range is that y value of the vertex, which is the bottom of the graph, the bottom of the well, the bottom of the canyon, up to infinity and beyond, like Buzz Lightyear said. Negative 12.25, right? So, good job, Michael. We are at negative 12.25. I don't need this open parentheses. Negative 12.25 less than or equal to y less than or equal to infinity. Okay. Not too bad. Now, we got the axis of symmetry, and this is the last thing. And the way that you do it is you write this, x equals, and then you tell me the x value of the vertex. What is the x value? 0.5. Very, very good. Now, let's zoom out so you can see everything you just did. Wow. Look at all that work. Yeah, round of applause to everyone. Now, let's do another one really fast, now that we have the groundwork laid. Okay. Write this down. We're going to go real fast on this one so you can see. In fact, I want to set a timer. Oh, cool. Tyler's watching. Hey, Tyler. Well, yeah, we'll work together, but I'll also be pushing you all along a little bit so you can see what speed you can get to. We'll start the timer here. Oh, boy. So, thank you, Hannah. Wow. You know what you get when we're done? You get a sticker for your journal for that. Yes, that was. Yes. Well, you can get both. So now, hold on. So we're doing good. Now this goes in the calculator. NY equals. Oh, man. Well, first we got to graph it and make sure we can see both of the intercepts. What I like to do here, and I mean, you're okay if you can figure it out without doing this. I like to put that little cursor thing right in the middle and zoom in on this thing. But you don't have to do that. I like to do that. So, because I can see the answers. What are the answers? No, that's not the answer. You look for where it crosses the x-axis. Count over with the hash marks. Okay, hit. Oh, you already got the minimum. Okay, good. Stay there. Hold on to that. So we need to find out what the solutions are. I need you to tell me where it's crossing the x-axis. Say it. Negative 10 and negative 4. Okay, good. No, it. Okay, here we go. So one of them is negative 10 comma 0. Thank you. Now, Michael's already got this, but we're now going to find the minimum of the graph by hitting second trace minimum. Yeah, second trace 3. And then we have to go to the left, enter. To the right, enter, enter. And you get negative 7 comma negative 9. So the vertex is negative 7 comma negative 9. Now, can you guys tell me what the y-intercept is? Look at the C value. Look at the C value. Yeah, so 0 comma 40. Now, the point of reflection, it's 2 times the x value of the vertex, comma, the y-intercept. So this one's 40. What's the x? 2 times the x value of the vertex. Negative 14. All right, domain's the same. What can we say?
Gracie, Wally, could you an office? Gracie, Wally.
All real numbers, okay? I'll put all reals, and I'll also write it the way it's going to be on the star test, which is negative infinity, less than or equal to, less than or equal to. Excellent. Now the range. This has a minimum, so we can use our rule. That would be the y-coordinate of the vertex. What is that? Mm-hmm. Oh. Comma. Or wait. I keep doing this wrong. So it's -9 less than or equal. Y. Yeah. And then finally, the axis of symmetry is the x value of the vertex. Let's see where we're at on the timer. Wow. Less than 5 minutes to solve all 9 parts. Now, on the STAR test, you will only be asked to solve one of the 9 things per question. Okay? Exactly. Yeah, I think on your own you could have, for sure. And if you want to take a picture, this is what I'm going to be doing tonight on the live stream. Just more of this. So I'm going to be continuing our table and just continuing the analysis. It will be. It will be. I'm going to distribute this page to everybody. Good job to everybody today in 8th period. Excellent work. Let's all give each other a round of applause. Special thanks to Michael and Hannah and Rodnisha and others for being excellent with the work there. And on that wonderful note, we will end our stream and say goodbye to all who have been listening. See you guys tonight on the live stream, 6 to 9, Athenian Stranger, and on Discord at Athenian Stranger, #87.